there is? Anyone? Come on. Yeah, it's a cirrhotic liver. It's a cirrhotic liver. And in fact, I'm personally doing some research at the moment to try and sort out where that patient came from and what disease they had. But as you can see, he got very accurately the aorta and the way it splits and goes down in the pelvis. With a modern scan, we can now fade out and leave what we want. You can see the erectus abdominis muscle showing beautifully there, and there is the pelvis, and you can see his drawing is pretty accurate of the aorta and its branches and the kidneys. So most of his anatomy was pretty good, though the heart at that stage was not. He also decided often to draw a single system, which in itself was very clever. And what we're looking at here is the stomach, and we're getting closer to Hack's area. We've got the stomach here and the duodenum. Here's the spleen, here's the liver, and you can see there is a big vessel going from the spleen into the liver. And here I've shown a modern splenoportogram. There is the spleen, there's the portal vein, there's the splenic vein, there's the portal vein, and you can see the liver. Oh, sorry, it's this very sensitive thing. And you can see that the portal vein is shown with a blue arrow on both drawings. Now, we know that he took this drawing from the old man called Vecchio, and we know this old man was 100 years old when he died, because he discusses the man being at his bedside and how sweet a death he died. And later, when he was dissecting the old man, he described the coronary artery thrombosis that killed him. Again, the first time that the pathology had been described, he noticed the artery was blocked, and this was what had killed the gentleman. But of course, there aren't many causes of a person being 100 years old and having portal hypertension, because I can assure you that alcoholism, which we see a lot of in England, does not let you live till 100 years old. In fact, you're lucky if you get past 60 with alcoholic cirrhosis. And it's possible that this gentleman was actually a sailor who'd gone from Venice to North Africa, where he picked up schistosomiasis. And we're at the moment looking into some work to try and prove that this body that was dissected in 1590 was actually a sailor who picked up schistosomiasis. Again, he took individual systems and brilliantly showed how the system, and this is the gallbladder, and we can see the common bile duct, and you can see I've put an arrow here at the common bile duct, and he drew the whole system. He was amazing at sorting out systems. But this is a very interesting picture. What amazes me is his ability as an artist to show the peritoneum. I don't know if any of you could draw peritoneum better. I don't think many people could. But you can see his little drawings of the vessels in the anterior abdominal wall. But here he drew the peritoneum, and Martin Clayton, who is the master of the Royal Plinths, who asked me to help him on this exhibition, said to me, I don't understand what all these things going into the umbilicus are, and what on earth is this tube going from the umbilicus into the liver? Well, I looked at him and I said, well, I know what it is. It's the remaining left umbilical vein, and there are 2 or 3 who's a pediatrician here? I know there's 1, 2, 3 pediatricians, okay. Pediatricians use this knowledge when they're doing exchange transfusions on babies, because they use this vessel here, which is still open in the baby, and it reopens in people that have got this disease, portal hypertension. So Leonardo obviously drew what he saw. He didn't cheat, which most people do, let's be honest. As an artist, he saw things and he drew them. So this yellow arrowed structure going from the umbilicus is in fact the remaining left umbilical vein. And these tubes which he drew going into the umbilicus are in fact the inferior epigastric and the lateral umbilical ligaments, which we know are remnants of the umbilical arteries. So everything that he drew was accurate, even if people didn't understand it. Now, I mentioned before that his original pictures of the heart were inaccurate. You can see, if you look at this picture, which is all on one piece of A4, here is a little valve, here's a heart, front and back, Here's a view of the heart, and look down here on the right-hand side, he's drawn individual valves, and he's drawn the venous supply going to the back of the heart. And some of you are going to say, well, that doesn't look very like a human heart. The answer is it isn't. It's an ox's heart, and it's a very accurate drawing of an ox's heart. But what was more important, he was trying to understand how these valves work and how they opened and closed. Because it may surprise you that this is 120 years before the description of blood flowing around the body via the heart, arteries, veins, back through the chest. In 1628, De Motu Cordis by William Harvey described the passage of blood. Now everyone in this room, whether you're medical or not, knows that the heart pumps out the blood by the arteries, it goes into the capillaries and it comes back via the veins. That wasn't described until 120 years after this drawing. And you'll see in the next drawing I'm going to show you that not only did he get an accurate idea, he didn't solve the problem, it took another 120 years. But look at this. What he did, this is a modern MRI scan. But what I want you to look at is all these little pictures with little whirligigs. And if you look at this one, you can see the aortic valve, and he did an experiment by getting millet seeds in water, and he made with the glass blowers a glass aortic valve, and he shot through water with the millet seeds, and he noticed that the millet seeds had turbulence and eddy currents. You've all seen this when you look at a river going through a narrow little gap in the river, and you can see it whirling past. It's exactly the same. He was a very good water engineer, and he realized that the closing of the valves was due to the eddy currents that come after they go through a narrow space in the water. And he actually drew it, and these little lines are his description of eddy currents. You see how he draws them like little whirligigs, little circles, and he actually did an experiment to show that the eddy current helped shut the valves. Now you may say, that's amazing, but let me tell you how amazing it is. It isn't until when we had MRI that we could actually see that. Modern science was not able to prove that until about 20 years ago, when the MRI showed us that the blood going through the aortic valve is spinning round and shutting the valves. So he managed in his experiment to show something that took another 400 years to actually prove that the closing of the valves is due to the eddy currents of pushing them down after the water has gone through them. This was one of his very first pictures he drew in 1485 to 1490, and he is the only person known at that time, or up to that time, to have done cross-sectional slices through a body part. And what he did, he showed where he was going to do the slices, he drew the slices, and on one slice he labelled all the compartments. And he labelled them accurately. What is fascinating, I can tell you as an anatomist, it is very difficult, unless you have freezing and a very sharp microtome, to actually slice through. Even the orthopedic surgeons will tell you, if you're doing a removal, actually doing an amputation, it's quite difficult to keep the anatomy under control. And yet he managed to do the anatomy and do the labelling, and all those labels are the correct compartments of the actual sliced leg. I mean, nowadays we can do an MRI, or a modern artist, and some of you may know Frank Netter's work, an amazing artist who did the Sieber collection, or the Novartis collection of art, and you can see nowadays we have a section which is exactly the same as that, and of course with the iPad you can press a button and all the labels come on, or all the labels go off, which is really quite clever. But just look at this, the first time anyone has done a cross-section through a leg. How many have seen this picture before in their lives? Most of you. Good. It's very famous. It's probably